What we're going to learn in this lesson is how to plot linear inequalities. We already know how to plot lines. And the difference that we're going to do now, though, is these equations are not going to have an equal to sign. They're going to have an inequality sign, like a greater than or equal to or a less than. And so that's going to be the difference in what we're plotting. Now, because these things have this inequality sign, the graph will not only contain some sort of a line that we're used to, but it's also going to have some shading on one side of the line or the other side, indicating that all the points that are shaded are solutions. That means if I would put any value in the shaded region into that equation, it would be true. And so these graphs are going to look slightly different than what we're used to. Now, one of the things that we're going to have to think about is how do we show whether the inequality has an equal to sign in it. For here in A, we have a less than or equal to or greater than equal to, so we do have an equal to still in the inequality. And for those type of equations, how we're going to show those on the graph is they will have a solid line for the actual line. And the ones that have less thans or greater thans, they do not have the equal to sign, those are going to use a dash line. And the dash line means that any point that's on the line would actually not be a solution. So let's go through this and talk about that just a little bit more. Okay, so here I have an example of a graph that would be an inequality, and we can see it's got 3 points on it. Now this point over here, this 4, 1 point, it's not in the shaded region. So if I would substitute this 4, 1 into the equation, it wouldn't work. The point 1, 2 is actually on the line. But because this line is a solid line, that means that all the points that are on that line work in the equation. It would be an equation that has a less than or equal to or a greater than or equal to, indicating that the line is also a solution. So if I would put the point 1, 2 in the equation, it would be true. The point -1, -1 is in the shaded region, so when it is substituted in, it would be true. It would work. Over here I have another graph, but it has this dotted line. We can see the point -4, 1 is in a non-shaded region. It would not work in the equation. When I substitute it in, it would be false. The point -1, -2, when I substitute it in, would also be false, because this particular equation would not have an equal to sign under the inequality. And so that would be a false point. And here I have 0, 0, and if I substitute 0, 0 in, it's in the shaded region, it would be true. Okay, some of the problems we're going to see are going to be to determine if a point is a solution to an inequality. So let's take a look at that. What we do is we actually plug the point in and we see if it works. So for this one, I have the point 2, 3, and I want to know if it's a solution of 3x minus y is greater than 4. So let's substitute that in. So I would get 3 times the x value, and the x value of that point is 2, minus y, and the y is 3, and is that greater than 4? Okay, so we've got 3 times 2, that's 6, minus 3, is that greater than 4? And I get 3 is greater than 4. Is that true? No. So that point is not a solution. 2, 3 is not a solution. Okay, let's look at the point 1, -1, and see if that works. So we're going to substitute 1 in for the x, 3 times 1, minus the y point. Now the y point is a -1, so that's going to be 9 minus a -1, and the question is that greater than 4? So I have 3 minus a -1. Is that greater than 4? Is 4 greater than 4? And the answer is no. So that is also a point that would not be a solution, and actually that point would fall exactly on the dashed line of that graph. Okay, let's look at how we actually plot a linear equality. So the first step we're going to do is when we see the inequality equation, we're going to look at it and we're going to determine if it is a solid or a dashed line. So if we see an equal to sign anywhere in the inequality, it'll be solid. If there isn't one, it's going to be dashed. And we're actually going to plot that line, this is step 2, like it has an equal to sign. We're not going to worry about less than or greater until we're done with plotting the line. Don't forget you got to determine whether it's solid or dashed, what you're going to plot. Now, then after we actually have this line plotted on the graph, how I put in the inequality part of it is I need to pick a solution or a point on one side of the line I graphed. I take that point and I plug it into the equation. If it works, I shade that side. If it doesn't work, I shade the opposite side. So let's see how all this ties together. So I have an equation here. Y plus x plus 4y is less than or equal to 8. Now this is a standard form equation, so I'm going to plot it by finding the intercepts. I notice that the inequality is a less than. That's going to make this a dashed line when I plot it. Okay, so let's go ahead and plot this line. So the first thing I'm going to do is I'm going to feed in a value of 0 for y, because remember I like to plot the intercepts when I have standard form. So if I put a value of 0 in for y, that would make this x is equal to a negative 8. And remember, what I'm actually plotting is I'm plotting x plus 4y is equal to a negative 8. So plotting a 0 in for y gives me x is equal to a negative 8. So that's one of my points. So there's x equal to a negative 8. Next, let's find the y-intercept. So for that, I'm going to put the x value equal to 0. And if the x is 0, I would end up with this. 4y is equal to a negative 8. So y would be equal to a negative 2. So the point 0, negative 2, would be another part. And so let's go ahead and plot the line, and it's going to be a dashed line, and I don't have a ruler, so this isn't going to look very good. My next step is to see what side of the line is shaded, so I'm going to pick some point and test it. The point 0, 0 doesn't have, the line doesn't pass through 0, 0, so that would be a point I could use. So I'm going to plug 0, 0 into the equation and see if it's true. So if I have the equation x plus 4y is less than a negative 8, if I plug 0 in, I get 0 plus 4 times 0 is less than a negative 8. Is that true? So 0 is less than a negative 8. Is that true? And of course that's not. So the point 0, 0 is not a solution. That means the other side of the line would have to be shaded. Okay, let's take a look at the next example. I have this equation here. 4x is greater than or equal to a negative 12. Now that's a strange looking equation. Really, it's an x equal kind of line. So what we need to do to this, I need to get this in a better form first. Let's divide both sides by 4. And you can actually see that this is the line x is greater than or equal to a negative 3. So we're actually going to plot the line x equals to 3, a negative 3. And that would be right here. And it's going to be a solid line because it has an equal to sign in it. And to determine what side we shade, a lot of you will be able to see that it says x is greater than a negative 3. That would be everything out to the right where all the values of x are greater than a negative 3. So this part would be shaded. And another way you could check it is you could, of course, always substitute in the point 0, 0. And if I did that, it's this x coordinate that would actually substitute in. So it would be 0 is greater than or equal to a negative 3. Is that true? Yes, 0 is greater than a negative 3, so the point 0, 0 would be shaded. So if I prefer to do the testing point method for those, I can. Now, for the parts that are vertical and horizontal lines, a lot of times you can see what side to shade. Do not use that method for these other type of lines. you will get a wrong answer. What you really need to do is you have to pick a point and test it. So don't just think or assume that you can tell because of this inequality what side of the line it's going to be shaded on. That's a really big mistake. Always pick a point and test it.